Number 5, we have sine of alpha plus beta times sine of alpha minus beta. We want to prove that that equals sine squared alpha minus sine squared beta. So I'm just going to focus on this side. We're going to apply the sum and difference formula. So with this one we have, I'm going to put them in parentheses, they're pretty big. Sine of alpha cosine of beta plus cosine of alpha sine of beta. So that's what we get here. And then this gives us sine alpha cosine beta minus cosine alpha sine beta. Alright, based on the appearance, we have difference of squares. You can see that these terms, well, this term is the same as this term is the same as this term. So shortcut, difference of squares, when we multiply this together, we would just get this squared minus this squared. Alright, so what that means is we will have sine squared alpha cosine squared beta minus cosine squared beta sine squared supposed to be cosine squared alpha, oops, sine squared beta. I just wrote the same thing twice. Okay, this is what we get when we do our difference of squares. And then from here we want maybe to apply the formula for the Pythagorean identity. So that is coming from this cosine squared theta plus sine squared theta equals 1. So if we apply this to the cosine part, because we want sines, we can subtract this and we'll be using this formula. Cosine squared theta equals 1 minus sine squared theta. Alright, so we're going to be substituting this form for the cosines. Alright. So that sine alpha sine squared alpha, and we're going to replace this with 1 minus sine squared beta, because the angle is beta, and then minus cosine is also going to get replaced. 1 minus, this time it's going to be sine squared alpha times sine squared beta. Alright, we're going to distribute through this negative. It's going to change both those signs when we distribute. So let's this pen is shorting me. Sine squared alpha when we multiply by 1, and then we multiply this minus sine squared alpha sine squared beta. Now this negative 1 is just going to change the signs of these. So this is going to be negative and that's going to be a positive. So that'll fix that. So when I multiply sine squared beta times negative 1 minus sine squared beta, and then times here we get plus sine squared alpha, sine squared beta. Alright, now if you notice, positive sine squared alpha beta, sine squared beta, negative sine squared alpha, sine squared beta. These will cancel each other out, and we're left with sine squared alpha minus sine squared beta, which is what we're looking for. So there's our proof there.